Hello and welcome to the fifth and final video in the Microsoft Azure IaaS Architecture Best Practices for ARM series. I'm Jeff Lankford, a Cloud Solutions Architect for the Microsoft State and Local Government team. In this section, we will be building out the load balancers and the network security groups using the Azure Resource Manager portal. The full listing of the videos in the series is shown here. We'll continue the build out of the full scenario in this video. The workload scenario that we're building in this video series is shown here. We've already built out the virtual network and created all of the virtual machines. Now we're ready to finish up the scenario by creating 3 load balancers, 1 public and 2 internal. Lastly, we will create 2 network security groups to allow inbound internet traffic for the ADFS web proxies and the SharePoint Web Frontends. Let's get started. Okay, here we are back at the portal, and what we're going to do now is click on New, and we're going to go into Networking, and we're going to click on Load Balancer. So the first one that we're going to create is for our ADFS proxy servers, which is a public load balancer. So that means that it will be available externally. So we'll type in here PLB for public load balancer, and that's going to be ADFS proxy. This type is public, so we need to choose a public IP address for it. And the one that we have here is our gateway IP, and that's in use by the gateway, so we can't use that one. As such, we'll create a new one. We'll call this one PLB ADFS proxy-IP. Assignment will be dynamic. We'll click on OK. Correct subscription. Let's use our existing resource group. Because this is a network component, and we're doing this in the east, we're going to put it in the resource group for the west network. And our location matches, so that looks good. Let's go ahead and click on Create. Okay, it validated and it's kicked off that deployment, so we'll go ahead and watch this here. It shouldn't take too long. In the meantime, let's go ahead and create both of our internal load balancers. More networking, load balancer. This time, this is an ILB for an internal load balancer, and this is for the SharePoint Web Frontends. Click on Internal. We'll choose the virtual network of where we want it. It's in West, that's correct. And now we're going to choose the subnet. This internal load balancer, since it's for the SharePoint Web Frontends, they're in the DMZ. So we're going to choose DMZ. And the IP address, you can either make it dynamic or you can make it static. We'll go ahead and put this as a static IP. .20.0, and let's go ahead and choose 30. Okay, that one is correct. It is available. I'm going to choose a resource group, and it's going to be the same one as before. RG West Network in West US, and we'll click on Create. Validation successful, and now that one's kicked off. Okay, let's do our third one here. Networking, load balancer. Again, this one is an internal load balancer, so it's ILB, and this is for SPSQL. SPSQL, internal load balancer, choose the network, VNet West. The subnet that this is in, since these are for the SQL servers, that's in the servers network. or subnet. Okay, we will make that static as well. So we will assign this as a 10.20.3.30. Same resource group, because again, it's a part of that network, or a GWS network. Go ahead and create. Validation is successful. That one is kicked off, and the other two have completed. So now we can go back here into all resources. And we'll go ahead and look here. Here's our load balancers. This is our public load balancer for the ADFS proxy. Okay, so we'll go ahead and click on the public load balancer for the ADFS proxy. And it'll bring up all the information about that. What we need to do is change the backend pool. Okay, there's nothing there right now because we haven't done anything. This is a brand new, newly created load balancer. So we'll click on Add. And we are going to call this the ADFS proxy. And it's going to be associated to an availability set or a single virtual machine. In this case, what we want to do is assign this to the availability set that we originally put these ADFS proxies into. So the availability set that we are going to choose is this one, availability set ADFS proxy. Go ahead and click on that. Okay. Click on OK. It will update that, and there we go. So now the ADFS proxy set is in there, so we're good. Now what we need to do is go into health probes. You have to add in a health probe. This is so that it knows what's available in the set. So we will call this health probe. TCP, port 80, interval is every 5 seconds, and the unhealthy threshold is 2 consecutive failures. You can change these, but we'll just go ahead and leave those at default. Click on OK. And it'll update that and add that in shortly. Okay, there we go. That's it for that one. So we can go back to all resources now. We'll go ahead and choose the SharePoint Web Frontend Load Balancer, and this is an internal one. Okay, our backend pool, it's the same thing, only this time we're adding in those SharePoint Web Frontends. We'll just call it SharePoint WFEs, and we're going to associate it again to an availability set. Choose the right one. Availability set for the SPWFE. And that looks good. Click on OK. It'll update that. All right. Same with the health probe here. We're going to add in just a standard port 80. Call it health probe. Leave everything else the same. Click on OK. It'll update that, and then this one will be done. If you need to include NAT roles, you can do that here by creating NAT roles. In this case, we don't need any. Same with load balancing rules. You can go ahead and create specific load balancing rules to move the traffic for certain pages or for certain services between servers if you need to. But since both of these SharePoint servers are configured identically, we just need to point directly to the WFEs and they'll handle everything else automatically. Okay, we'll go back to all resources and we'll do the last one here. This is the one for SQL. Okay, backend pools, add in. Okay, we will call it SP SQL. Associate it to availability set again. And we will choose the SQL servers. We'll click on OK. That'll go ahead and get updated. There we go. Change the health probe. Now this is a SQL server, so it doesn't necessarily have IIS installed on it. So a port 80 TCP, if there's no service there, that isn't necessarily going to work. So we will just go with 4.4, or with actually 1433 TCP. And then we'll call this health probe. You can use the same name here for the actual probe itself as, between multiple different groups here, because each one of these is isolated within this specific load balancer. So repeating these names doesn't hurt anything, and it describes exactly what it is. Okay, we'll click on that. And there we go. So now our 3 load balancers are all configured. That's all that we had to do. Go back here to all resources. And the next thing that we're going to do is create 2 network security groups. And these network security groups are going to allow us to allow inbound internet traffic for the ADFS proxies and also for the SQL server, or I'm sorry, for the SharePoint Web Frontends. Okay, let's go ahead and click on the green add here. And we're going to go into networking. And we're going to choose a network security group. Click on create. Our name is going to be NSG-allow inbound internet. Again, we're going to put this in the West Network Resource Group, location of West US, and we'll click on create. Okay. It'll go ahead and deploy that. Shouldn't take long. And then as soon as that's done, what we'll do is we'll go in and actually put the rules in there. Deployment succeeded. Okay, it's now there. Click on all resources. And here you go. Network security group, NSG, allow inbound internet. Let's go ahead and click on that. And what we need to do is set the inbound and outbound security rules. Okay, we will click on inbound security rules first. And if you click up here at the top, you can see default rules. Let's go ahead and do that. You're always going to have these default rules in all of the inbound and outbound rules. If you want to modify them, you can, but you typically just leave these alone. So we're going to go ahead and create a new one. And what we want to do is lock down the DMZ so that we allow inbound internet traffic. By default, any inbound internet traffic is not enabled. So you have to explicitly enable that. And that's what we're going to call it here. Allow inbound HTTP. So our priority, we'll make it 100. And we're going to use tag as the source. So if we go to a tag here, you can look in the drop down, and there's Azure Load Balancer, virtual network, or internet. In this case, we want internet. Service, we'll leave it custom, any protocol, and port range of 80, which matches HTTP. So that's perfect, and we want to allow that. Click on OK. That will update and show up here in a minute. Okay, there we go. One more we need to add in here, and that's HTTPS. This priority, we'll make this one 101. Again, it'll be tag, internet, custom, port range is 443. And it's allow. We'll click on OK. It'll go ahead and update that. And there we go. We now have HTTP and HTTPS. Now, if you wanted to, you could add in additional outbound security rules. So for instance, if we wanted to say that the DMZ cannot communicate to one of the different subnets, maybe the DMZ can't communicate to the identity layer, or you don't want it going to the server layer or something like that, you could add a rule in there to make sure that the outbound traffic can't go there. In this case, however, we need to be able to communicate to both the identity subnet and the server subnet, as well as the application subnet, because the SharePoint load balancer is going to require access to all of those. So we will just go ahead and leave it at this. Okay. Now we're going to go down here, we're going to click on subnets, and you'll see that there's no subnets listed here. We went ahead and created these rules, but they're not bound to anything. What we want to do is we want to associate this newly created network security group with the DMZ subnet. So we will choose the virtual network, and now we will choose the subnet, DMZ, and we'll click on OK. And there we go. So now this subnet contains this network security group, so the DMZ will allow inbound internet traffic. None of the other subnets will allow that. Okay, now we're back here at all resources, and we're going to go ahead and create our next network security group. This is going to be the one for the east, which is going to be configured exactly the same as we did for the west. So we'll go down here to network security group, choose that, click on create. And we're going to call this NSG allow internet inbound east. Click on use existing. We're going to change to East US. and we'll put this in the East Network resource group. Go ahead and click on Create. And it'll go out there and create that. Okay, it has been created. So we can look at all resources, and then we'll go choose that security group, allow Internet Inbound East, click on that. Again, we'll go into the inbound security rules. Take a look at those defaults. Those are the same. We want to add in Internet or HTTP and HTTPS. Okay. Allow HTTP. Priority is 100. Tag is Internet. Services custom. Port range is 80. Click on OK. Once this is updated, we'll click on Add, and we'll give our HTTPS rule as well. Okay. Allow HTTPS. Priority is 101. Tag is Internet, and the port range 443. Click on OK. Okay, there we go. So we have HTTP and HTTPS from the Internet. Now all we need to do is assign these to the subnets. Again, the same thing. We're going to associate this. This time it's with the East Network, and it's going to be in the DMZ subnet. Click on OK. That association will take place. And there we go. So now you've seen how you can create network security groups to lock down the traffic within these different subnets. You can also supply or apply a network security group to a specific virtual machine NIC if you want to. So that gives you even more flexibility. If you have one machine that you want talking only to like one or two other machines or to only certain traffic, you can lock it down there. But in this example, we just simply locked down the DMZ, or we saved the automatic security for all of the other subnets, which is by default to not allow inbound internet, and we opened up the DMZ subnet on both the east and the west to allow internet traffic. You can further lock it down if you have lots of different types of security needs. You can allow certain services, disallow others, etc., all through this interface. Okay, so in this video, we have created our load balancers, and they're done. We've created the network security groups, and they're now done as well. This builds out the entire scenario that we presented here in this series of videos. So we're now pretty much done with everything. On the Azure side, now that all of this is complete, you can then remote into each of the individual VMs, configure their roles, join them to the domain, and do all of the things that you need to do to make these functional virtual machines. But from an IaaS architecture perspective, in Azure, we're now done. We are all complete. So that concludes this series of videos. I hope you found them useful. Thank you for watching.